Hello everyone, welcome to Ganit Gurukul and this is Yogesh Garg. In this video, we are going to discuss JEE Advanced 2021 Paper 1 question number 11 and this question is based on matrices and determinants. So let us start. For any 3 into 3 matrix M, let del M denote the determinant of M. Let E, we have three matrices, right? E, P and F. Fine. If Q is a non-singular matrix, what is the meaning of non-singular matrix? Meaning of non-singular matrix is that del q is not equal to 0. If del q, that is determinant of q is equal to 0, it is a singular matrix, and if it is not, then it is a non-singular matrix. So it is a non-singular matrix of order 3 into 3. Then which of the following statements are true? So this is a more than one choice correct question. We have four options. First, we have to check whether f is equal to PEP and whether p square is equal to identity matrix. See, this is identity matrix I. So we have to check whether p is equal to p square is equal to I. Also, we have to check whether f is equal to PEP. I hope that each one of you is able to observe one thing, one very peculiar, interesting thing in P as well as in E and F. See the elements of E and F. See, observe the elements of E and F. They are same. They have been arranged in a different manner. That is the point of contention, but they are same. So there must be some relation between E and F. Fine. Also, carefully observe the P and I. Carefully observe the difference between P and I. The second row of P is 0, 0, 1 and third row is 0, 1, 0. If we just interchange the rows, second and third row, we will get I. So this is a certain sort of observation that we must be having at the beginning of the question. Also, what you can observe that in E as well as in F, actually in E, or we can say in F also, elements in a certain way are in AP. That is 1, 2, 3, it is in AP. 2, 3, 4, it is in AP. 8, 13, 18, it is in AP. So what if they are in AP? What we can say about it if they are in AP? I hope you must be familiar with this property. If elements of row or column, but it has to be true for all the rows and all the columns or all the columns. So if elements of row or a column are in AP, then determinant of that particular matrix is 0. Seriously? Yes, that is true. I can show you. We can easily observe this. See, we have 1, 2, 3 as the elements, right? 1, 2, 3, 2, 3, 4, 8, 13, 18. Just do one thing. Use this operation. R1 to R, or let us say R3 to R3 minus R2. Fine. Okay, actually this is not a part, we don't know whether we need it or not, but I am just exploring, I'm just discussing this for exploration. Just explore. We should be familiar with this property. Fine, we should be familiar with this property. We need not to check it, verify it in the exam itself. We should be knowing this beforehand. Okay, so R3, we will transform R3 as R3 minus R2. We will get 1, 2, 3 minus 2, 1. 2, 3, 1 again, 8, 13, 8. Fine. So we have this thing. Now again use one more operation. Use this property. R2, transform R2 to R2 minus R1. Do this. Do this and you will observe something very interesting. 1, 2 minus 1, 1, 1. 2, 3 minus 2, 1, 1. 8, 13 minus 8, 5. I'm sorry, this should not be 8, this should be 5. 18 minus 30, it should be 5, it should not be 8. Now, 13 minus 8, 13 minus 8, 5. Then 5. Can you observe this thing? Second column and third column, they are identical. It is same, they are same. Determinant of this particular matrix should be 0. That is the point over here. Determinant of E, and similarly If you will calculate determinant of f, it will also be 0. Determinant of f if is also 0. You will say that 1, 3, 2 they are not in AP, but if I interchange the this third and second column, terms will again be in AP. Fine. So determinant of E is 0 and determinant of f is 0. We should be familiar with this thing, right? Determinant of E and determinant of f is equal to 0 over here. And I'm saying we should be familiar before starting the question itself, before reading the options. We should be familiar with this property. Fine, because this is something which will save our time in the exam. Okay, so now we are starting the question. We are starting the question. So first option is to check whether f is equal to PEP and P square is equal to y. Second, we have B option is something EQ plus PFQ inverse, determinant of all this is equal to, fine. C option is EF cube, determinant of EF cube is greater than determinant of EF square. Now we know something very interesting, isn't it? We know something very interesting, the property of determinant. This is EF cube, determinant of EF cube, and that can be written as determinant of EF whole cube greater than, we have to check whether this is true or not. That determinant of EF cube is greater than determinant of EF square. Is it true or not? Now there is something very interesting. Determinant of AB can be written as determinant of AB. I hope the screen is visible to everyone. Determinant of AB, that is AB determinant, is equal to determinant of A into determinant of B. Now determinant of EF cube will be determinant of EF will be determinant of E into determinant of F, 0. So left hand side is 0, right hand side is 0. How can 0 be greater than 0? How can 0 be greater than 0? It cannot be, right? It cannot be. So C option is obviously incorrect. This is also a good important thing. We should be eliminating the incorrect options. So C is eliminated. Fine. Then we have sum of the diagonal entries of P inverse EP plus F is equal to sum of diagonals. So this thing we can be able to do. We will be able to do only after checking whether A option is correct or not. If we are able to find out, if we are able to prove that P square is equal to Y, we can easily check whether D option is correct or not. So now let us start. Let us check whether F is equal to PEP and P square is equal to Y. Right. So this is E, this is P, or this is F. If you observe very clearly, if you observe this is F, this is P, fine, and this is E. So PE is, how to evaluate PE? This is first row, this is first column. You multiply, you add the corresponding elements. I am not doing the whole calculation. I am just showing you the required expressions. PE is equal to, first element will be 1. Fine. Then 1 0 0, first row, second column. So now it will be 2. Fine. Then it will be 3. First row, third column. So 3. Then second row, first column. So it will be 8. Over here we will get 8. Similarly 13, similarly 18. And then we will get for 0 1 0, third row, first column, 2. And then we know 2 3 4. This is our PE. Now how to find PEP? Just post multiply this with P. P is 1 0 0. Now we are doing post multiplication. Be very careful about it. Now we are doing post multiplication, not pre multiplication. So we should be very clear with what is pre multiplication and what is post multiplication. Fine. So multiply this, post multiply this. 1 2 3 1 0 0. We will get again 1. Now 1 2 3 0 0 1. Be very clear about it. First row, second column. So 3. Fine. 1 2 3 0 1 0. It will be 2. 1 3 2. Now we can clearly see what is going to happen. Columns will get interchanged. Fine. Second, we will get second column. We will get third column in exchange of second column. So we are getting 1 3 2. Then we will get 1 18 8 18 13. Then we will get 2 4 3. Okay. So this is our PEP. This is our PEP. Fine. And F is the same thing. This is PEP and F is the same matrix. PEP and F, they are equal. Fine. PEP and F, they are equal. These two matrices are equal. Also, we can check that P square will be equal to I. This is something which I am leaving to you. You should check it by yourself. But you, for sure, I am able to observe this, that P square will be equal to I. This you can check by yourself. Fine, I have showed you the way out. Okay, so check it by yourself. But you will be able to see that P square is equal to I. So this is true. P square is equal to I. Fine. Now if P square is equal to I, if P square is equal to I, it means first option is correct. F is equal to PEP and P square is equal to I. Fine, first option is correct. Now how to check the validity of second option? How to check whether second option is correct or not? We have del EQ. We have del EQ plus PFQ inverse. Fine. On left side we have this thing. Now we know what is F. And replace it so that we get an expression in terms of E only. Fine. Replace F. So EQ plus PFQ inverse can be written as determinant of EQ plus PF. F is PEP into Q inverse. Now we have EQ plus P square EP, and P square is I. So I into anything, it is the same thing. So I into E, it will be E only. So EPQ inverse, determinant of this. You can take E common, so you will get determinant of E into determinant of Q plus PQ inverse. Now determinant of E is 0. And you multiply anything with 0, you will get a 0. See? So I say this, you can say adage, 0 से टकराएगा वो चूर चूर हो जाएगा. Fine. So that E into anything, it will be equal to 0. That E is 0, 0 into anything is 0. 0. 0 is our answer on left hand side. Whether right hand side is equal to 0 or not, we have to check. Now clearly on right hand side we have del EQ. Del EQ, and you know del AB, that AB is equal to that A into that B. So that EQ will be equal to 0, isn't it? Similarly, PFQ inverse, determinant of PFQ inverse will be equal to determinant of P into determinant of F into determinant of Q inverse. And determinant of F is also equal to 0. So it means on right hand side, both the expressions are equal to 0. On left hand side we have 0, on right hand side we have also equal to also 0. So B option is also correct. Now, and it is very important, for more than one state question, you have to check all the options. Fine, C is incorrect, it is very clear. A and B, they are correct, it is very clear. But you should be checking D also to get full marks in more than one choice correct question. Fine. Also, in case D is not correct and you blindly mark it, you will get a negative mark. So be very careful about it. Check all the options. Check all the options very, very carefully. Then mark the final answer. So D option is P inverse EP plus F. Now, how to find this P inverse EP? It's not difficult. It's not difficult at all. We know that P square is equal to I, and through this we can say P is equal to P inverse, isn't it? See, P square is equal to I. It means P into P is equal to Y. So it means P is equal to P inverse. There is P inverse I, and that is P is equal to P inverse. No issue in that. Fine. I hope screen is visible to everyone. Or let me write it downwards. Fine. So it means P is equal to P inverse. So P inverse EP is nothing but PEP, and PEP was F. So it means we have sum of the diagonal entries. This C, P inverse is P. This is P, PEP. Now PEP is F. So F plus F, that is 2F. So sum of the diagonal entries of 2F. Fine. Now we have this thing, E plus P inverse FP. Now how to evaluate this? How to evaluate this? No issue, no issue. We have E plus P inverse FP. Okay. E plus P inverse is again P. So PFP, and F is PEP. So E plus P into PEP into P. This is what we have to find. This is the matrix which we are trying to find out. And now it is E plus P square is I into anything, it is the same. So I into E, it will be E only. E into P square, it will be E into I, and E into I is again E. So E plus E, 2E. So what we have to check is whether sum of diagonal element of 2E is equal to sum of diagonals of 2F. Now E and F, we know they were quite similar. Sum of, if I multiply this with 2, if I multiply a matrix with 2, each element of the matrix will get multiplied by 2, nothing else. Same goes with F. So it all boils down to checking the sum of diagonal entries of E and F. Sum of the diagonal elements of E is 1 plus 3 plus 18. And sum of diagonal entries of F is 1, 18 and 3. That is the same. So sum of the diagonal elements of E and F, they are equal. So whether you multiply it with 2 or 3, but if you are multiplying E and F with the same quantity, so they will be their diagonal sum is same. So it means D option is also correct. D option is also correct. Fine. So answer to this question is A, B, D. C is incorrect options. A, B, D are correct options. So I hope this I am able to explain you clearly. In case there is any doubt and you wish to ask, please do so in chat. If you wish to give any feedback of your learning, do so. Please do so in the chat itself. And stay tuned. Keep watching Ganit Gurukul.